Hello Internet, I'm Benny Jørgensen, adjunct at Lillebælt Academy of Higher Education. Today in this video we'll look at socket in C#. So first of all, why sockets? So we have to talk a bit about what is client-server architecture. Also, what is a socket connection? And then we move on to 3 demos. First of all, a very simple socket connection in where you can send a text back and forth between your client and your server. Then a multi-threaded socket server that are able to connect to several clients. And least but not last, because we don't want to send text all the time, we might be able, or want to be able to send other things. So we'll look a bit about how we could send objects over a socket connection. So just get started. In this diagram we have a client and a server, and client is the one with the initiative. The client is the one who does the stuff, and in this case it sends server data to the server. Usually we also piggyback data so we can reply, and the common example is if we look at MS SQL installation, we usually have an database server somewhere which actually stores the data, and then we have this management console that Microsoft uses to connect to the server. We know that we can have several management studios open connected at the same database. It can even look at the same table. So in this example, when we send data, it could be select whatever from some table in some database, and the piggyback data will be the table itself, which is the data we are requesting. This is the server, the request response pattern. So this is we request data from the server and it responds with it. It could also mean that we want to send some data to it and it says simply okay or not okay, depending on if it received the data or accept the data that we send it to them. So we actually have a client and a server, so we are going to create 2 programs, one that can talk with the other, and there are slight differences. So even though the diagram at first look alike, let's take a look at what it does. So at first we have a setup client and a setup server. These are not totally similar, but there are similarities. The next box is the client connects to the server while the server waits for a connection. And waiting is actually what servers are best at. They don't do anything on their own, they wait. Then they get a request, they do something, and then they respond to that request. After connecting to the server, we are able to send data, and we can see over at the server side again, the server is waiting for the receiving of these data, and then it does something with them. And we continue that until we close the connection. And as I said, connect to a server means that we can go on to the next box. Sending data means we can go on to the next box. The initiative here is totally on the client side. The problem with this architecture is that we can only connect one client at a time. Don't worry, we will solve that later on in the video. But first, let's look at a demonstration. And for that purpose I have opened 2 Visual Studios. As you can see, they are completely blank. And we will start out creating the server at first. Then we have something to test up against. So I'll just simply create a console application, and I'll find where I want to locate this. I'll locate it in the socket, and I call it a server, like this. And the other one I'll start up here is, I still use as a console application. You can use whatever you like to use. Code socket, choose that, and say client. and we're good to go. First of all, we need some socket. And we want to get a using the system.net sockets. And what we want here is to create a new listener socket. So we like to say address family. Oh, sorry. Address family is internet network. And we'll have socket type, which is stream, and protocol type is TCP. This is the setup of the server we are doing now, and we need to know what IP endpoint. Oh. And we're taking that from system.net and saying we like to create an endpoint. I'm just running on localhost, like that. The way a socket connects is through a port. It can connect from IP address to IP address using a port. You could say that an IP address is like the address of my house, while a port is the name of the door, the number of the door. So we are sure that we connect through the same door at the same house. I'm running both systems on localhost here, so that's why I got this IP number. In reality, it would be in here, as this is the server. The reason why we put in an IP address of the server is that a server can have several network cards, and we only wanted to listen at one of the cards. Or you could set up a loop so it listens to all the cards. In this case, we listen to the localhost and the other application transmit to localhost. So in here you will write the IP address of your server, the IP address that you want the server to listen on, and you decide a port number. The first several port numbers is reserved for some purpose, so we take the higher number, in this case 8888. There are 65,000 port numbers. Yes, we set up a socket and we set up an IP endpoint, so now we need to connect these two. We do that as a listening socket and bind the endpoint to the IP endpoint. Like that. Then we tell the socket it should listen. Like that. And there are details that I'm not going into. For example, here what is a backlog and what is the connection queue. We just want a simple example to work. So now we've set it up to listen for a client connection. Next thing we want to set it up for is to say create a socket, a new type of socket this time. We call it client socket. client socket comes out of the listener socket when it has accepted a connect from a client. So we have a listener socket who listens to new clients, and we have a client socket that contains the socket connection when we actually have connected to a client. And what these client servers are doing is transmitting byte arrays back and forth. So I'll set up a byte array like this and call it a buffer. New byte, and its size will be set buffer size like that. So it is the client who decides how big a buffer we must have. The reason is that we don't know how many bytes we will receive until we have received them, but we have to set up the buffer before we get the data. We do it like that, then we'll get a huge buffer with lots of zeros in it and a few data. We'll come back to that part later on. So in here we'll say int read byte client socket dot receive buffer, like that. So what it does is it returns the amount of data we have received and at the same time fill the data in this buffer. And then we can say to it that, let's just say console write line read byte, like that. And very simple socket server. The only thing it actually can do is receive one response from the client. So let's, wrong. So let's look at the client side instead. So on the client side, we set it up to say socket, using that one. So socket, let's just call it master, it sounds great. It's a new socket and we set it up to be a address family like the other one. We can actually just copy that part here. Using that one, and I said let's call it master. We use of course the same port, otherwise they can't connect, but as both applications run on the same machine. Oh, by the way, this IP address is the IP address of the server. Both application runs on the same machine, so it will be the same IP address in all of our case. But this is not the client IP address. We don't care about the client IP address. We care about the server. So the server must know what network card to connect to. It could be it has several network cards. Mine has two. A cable network and a Wi-Fi network. Maybe even the Bluetooth network, I'm not sure. And in this one we say what network card do we want to connect to. So this is the IP address of the receiver. So, and that's why these are totally alike. Then we connect the master to this IP endpoint. and master.send. And as I said, what it sends, we can see here, what it sends is byte. So what we'll just say is, I'm not making a using for that one. Using text, encode, I'll choose UTF-8. I'm too fast here. Encoding UTF-8. And pay attention here, strings is 2 bytes per character. And we are decoding it, so we are saying 1 byte per character. That means that all the special characters will probably end up wrong. So if you're from a country with lots of weird charts, like in Denmark we got EUO, then it's not then we're not sure it can be transmitted correct. Then you have to use UTF-16, which means 2 bytes per character. But for this case, we take 8 and say get bytes and just transmit a string, simple string. And that's it. Let's finish there. So we'll start the server, build it, hope it works. And it started down here, let's see. And we can start our client. It will start up and stop again, like that. And it says it got 3 characters, so we are happy. 3 characters is exactly hey. This is not very useful, it is the most simple example. So let's change our client here to say write line and say this is the client. Very genius like. And down here we'll say we'll create a string and we'll say do send data dot length greater than 0. That ought to do it. So we have a text called send data and we'll loop through that as long as there are data to send. And then we say close, just to close the connection in a polite manner, like that. And let's evolve this one here, saying we have accepted the data. So let's say while true here, just to receive the data. So as long as we are receiving data, continue. And we have to do a bit more there. client disconnected. And I said that we get this amount of read bytes because that our buffer is huge and we're probably only getting filled up with 3 characters, for example, in our last example. So instead we can say we like to print out whatever we get. And if we do that now, it will print out 65,000 on my machine bytes, which is a lot more than the 3 we have. And I'm not very interested in all the other bytes that we didn't receive. I'm only curious about the ones we did receive. So I'll set up a new buffer saying like this: byte receive data equals new. And now we actually know how many bytes we received. So let's put that in here and say array, just copy. The good part about copying an array is that we can say, okay, we want to copy from our buffer to our destination, and we only want to copy the amount of read bytes, because now we can say sorry, mishit something here. We got, then we can say this part here. Of this new thingy here. So let's roll the server once again, and it starts in my other window. And let's roll the client, and my client also opens in another window. So it says data to send. Hey, I'm Benny. Client disconnected. Everything's fun. That was the simple client in which we could send data back and forth. But if we look at this, we can see we have a little slight problem here. We want to be able to connect with several clients at the same time, and we couldn't in the last design. And if we look carefully here at this design, we can see that we still have a client. We set it up, it connects, it transmits data. We have the loop here, a do-while loop, and it can close the connection. So we're done with the client, we're happy here. But how about this? It looks a bit different, and it's because first of all we're setting up the server as we did before, and then we wait for a connection as we did before. But we need to change a little bit. So what we do is, whenever we get a connection, we go down here and create a new thread, and the new thread will once again listen for a connection, while the original will just continue to receive data until, as long as it gets something, and if it doesn't get something, it closes the connection. So this is why we set a multi-threaded version. So every client gets its own thread, plus we have one thread listening for new connections. Still, we have this connects to server, hits this error, as I said, just before we create the new thread. And all this will be in the new thread. Which means that if we got 10 clients, we will have 10 wait for data to receive doing stuff with it, 10 threads running like that. And I said before that what servers really are good at is waiting. So all these threads will just be waiting for the client to do something, and then it will execute and respond to it, maybe even transmit data back. Like this. Here we can see it sends data just down to that one. If we get a new client, you can see here, I'm trying with colors to show you that it just takes a new copy of that into a new thread, and you can receive all the data you want. So let's look at it in action, in real action. Here we got the server and the client from before. Maybe I should just show you a little thing that I actually forgot in the simple server. So just before we make it client side and all that stuff, we can look at, I said in this simple example here we can send some data, but I said we can also piggyback data to be sent back again. And it's quite easy. So I'll just put it in here because I forgot it before I showed you the slides. So I say here, when I have received some data and we have printed them out. So that is the receiving part. The receive part. And here we got a do stuff part. We handle our data. And then we piggyback something to send back. And I'll do it very, very simple, just so you can get the idea of what we can do here. So I'll simply say client socket.send. And I said it's always bytes that we are sending. So in this case I'm just sending 4 bytes of random code. Like this. This is the piggyback part. And I know it's hard-coded data. In here you could calculate a checksum, or you could, if it were an SQL server, it could look up the data and format them in some way and send them back. And here we're just sending them back, and of course we have to change a bit on the client as well, because then we want the master to be able to receive. And again, in here we'll just say byte piggyback data limit equals new, and we know, as it's hard-coded and as I just want to keep this example very simple, we just say okay, we got a 4-byte buffer for that part, because in this case we always know we only will receive 4 bytes of code. So let's receive these 4 bytes and just say we'll put them in the piggyback buffer, piggyback data buffer, and we can actually we can display them. Here we can just steal this line here. And said we got this piggyback data that we want to show, and we can just show it very briefly. So we can say here, and it says back ABCN as the ASCII characters of the numbers I sent you, and you can see whatever I sent here, it will return the same thing each time. So now we can piggyback data, but it wasn't what we wanted to talk about. I really wanted to show how do we do a multi-threaded version of this. And the client is just as good as we ever wanted, so I'm not going to do anything with the client now. What I'm mainly concerned of is doing the server in a better way than we did before. So here we have the server. And we bind it. Well, there we bind it. And we have this loop that will continue to listen to new connections. So we'll just move the listener part up there, saying, okay, you have to listen to this. And you have to accept new incomings. And now when the new stuff comes, so I'll make a new line here. And say, okay. Oh, that was, yes, so using threads, saying client thread. And at the client thread, we want to create a new thread. And we just want it to start a client connection. And in this client connection, we want to put the accepted client socket in it. Like this. Yes, and it's angry because we haven't created this one yet. And just create it up here. Oh, let me show you an easier way to do it. We just right click and say quick actions and generate it. And F12. And we'll go down here immediately. And what we want to do in here is pretty much all this. Like that. Yes, sir. Now we're rolling. Guess that was it. So let's try and start our server. Here it is. And if we look at the client, we can say, please show me the path to the client. So we can get a client. So let's see here. Data to send. Benny. Oh, I must have missed something in my server. Wait a minute. Yeah, I forgot to start the thread. Client thread. Start. Sorry. So now it started. So I'll have it up here, and I'll start a client here, saying Benny. You can see it received Benny. And now I can start several clients. Here I say Otto. Starting a client more. And these are running in there each thread. Could we show that in some way? Other than they can still receive. I guess we can, so let's just close the client here. Sorry, I didn't close it nicely, so now it's angry with me. What we could say up here when we are creating the threads is that say while true, we can event the client number and we can send it with here. So whenever we print out what we got, we can say that we got it from a specific client number, like that. So let's start the server again, and I'll just start a few clients. One say client 2, and client 3, and client 2 will respond again. Yes, everybody's happy. So now we have a multi-threaded, or actually we have changed a very simple example to a multi-threaded example instead. Doing it like this. I'll just scroll over the code. You can pause the program, you can pause the video at any time and look at the code, of course. So this is the main up here, where we are setting up the server, starting the while loop that will run forever. And of course it won't run forever, but you'll have to set up some kind of stop condition here. And then we start by listening to it, and whenever we got something, we create a new thread and push it off to this new thread. And this part is what each thread is running. So it's simply just say, okay, I got a buffer in this thread, and I receive them, and I do stuff with them, and I piggyback stuff with it, and eventually we can disconnect it. This is done a little bit more nicely than the client. But for now we're just sending bytes back and forth. We might want to send some more. So if we look at this example here again, we can say that we have a client and a server, we send data and we piggyback data back and forth. What we really want is not to send bytes arrays all the time. What we really want is to send objects, formatted data. And we could create our own, transform this data into a byte array and transform it back again. It's lots of coding. We could, as very simple, create a binary stream from a serialized object, and we call that data transfer objects. These are not domain objects or view models or something like that. These are objects created only to transmit data back and forth between the client and the server. So let's look at, here we got the server, and here we got our old client. And how we do that, it's a little bit tricky, so please pay attention. We add a new project, because it has to be the same object when we serialize it. It's not enough to create a car object of the type of the class car and create the class in each. That's because when we serialize it back and forth between a binary string, a binary array and back again, the .NET Visual Studio.NET platform will do it using the specific class library that holds the object ordinary. But I'll show you. So this data transfer objects, so we'll create an entire project for that. You can see here in our solution Explore, and we'll just rename that to car, just to keep it simple. and you can create the objects almost as you like to. The only very important thing is here to make it serializable. So the important thing here is to make it serializable. And I can say in public car. And as we have said serializable, it has to have a constructor like this. By the way, why doesn't it? Oh, sorry. An empty constructor. It has to have an empty constructor. But we can make constructors as well. If that's what we like. Okay. So let's create such one. And up here, this is in the server now. We are referencing the same. So we'll browse here. And we have this socket client in socket, client, DTOs, and binary. We can just say, oops, we need to compile it. So build solution. Cool. Now we got the DTOs. So now we have the reference to a DTO. And that's very important. So now we can, on the client side here. So let's just transmit data to read and to send. I'll just highlight them there for later use. And we'll just say here we will have a static byte, and we will call it car to byte. Oh, I know what we're missing. We are missing the reference here to DTOs. So DTOs.car, we'll take a car. So now we've got the car and we just want to translate it. So we'll say BNA in the binary formatter. We need a binary formatter, please. And we need a do I misspell something? Oh, it's just not that fast. Yes. A new memory stream, and then we say our binary formatter serializes into the memory stream, and it takes our car object. And we of course return the memory stream converted into an array. So now we can use this method here to say master.send. And what is it we really want to send? We want to send a car transformed into bytes. So let's create a new car. And let's make it a old BMW. That's a cool car. So let's send that. But our client is yet not ready to receive it. Oh, sorry. Well, our server is not ready to receive it. Or actually, it is ready to receive it, but it's not ready to do something about it. So for here, we are just changing what we do about it, and we can create our helper method here, saying private static dtos.car. Let's get the data in. And we want to have the memory stream from before. Here we are. And we are using the binary formatter, and we are using system.io. And we now take the memory stream and write stuff to it. And what we're going to write is the in data. And it leaves the option of, do we want to start at the very start of the array? Yes, we do. And do we want to have it all with us? Yes, we do. So we write the entire stream, and we must move our cursor back again. So we'll say we move it back to 0. Seek origin is begin, like this. And we get an object, we call it binary form decentralization of the memory stream. And then we can return object dtos.car and our object. That was lots of work. So we can say byte to car and read data, yeah, like this. And console write line c.make plus c.year to a string. Happy! So let's see if we can get our BMW from the client to the server. And there it is. Which is the conclusion of a 50-minute long video. So thanks for watching. It can't be any shorter. It is a tough topic, and I have only scratched the surface here, but I hope, really hope, that you have enough to move on with. Thank you for watching.